everybody. In this video I am going to show you how to find the mistake in applying lohpital role or an erroneous use of l'hôpital's role. For example, find the mistake and the string of equalities. In this example, I think here we can write this example: lem x squared e to power x minus 1 approaches x 0. If I ask you one question, where is the mistake here? Find the mistake. Where is the mistake in this string? I think here apply the first time here l'hôpital rule, because here derivative of x squared to x over e to power x. This is the derivative e to power x minus 1, because minus derivative minus 1 is equal 0. Okay, well, when substituted here substitute x by 0. Here 2 times x 0, 2 times 0 0. I think here the mistake, because here 0 not 2. Okay, to get it the final answer, I think here 0, the final answer 0. Let's show you how to correct this mistake. The first step, as applying l'hôpital rule, you should substitute the first step. Substitute x by 0. This is to check if we can apply l'hôpital rule or not. Here 0 squared over e to power 0 minus 1. This is equal 0 over 1 minus 1 equals 0 over 0. This is l'hôpital case. This is the first case, the main first case. This case 0 over 0. Now the second step, this is the first step, substitute. The second step here, apply l'hôpital's role. Okay, let's see here the first. Okay, derivative, this is, we can write here lem x squared over e to power x minus 1 as x approaches 0. This is equal lem as x approaches 0, derivative of x squared to x, here derivative e to power x, derivative minus 1 0. Okay, now we can substitute here to get it 2 times 0 over e to power 0. This is equal 0 over 1. This is equal 0. This is the specific limit 0. We can write finally lem x squared over e to power x minus 1 as x approaches 0 equal 0. Okay, this is in this case I showed you how to find the mistake. Okay, let's go to the another example. Here simplification of the indeterminate form, infinity over infinity. Okay, before go, just I think all these should go down. Yes. Okay. Here, simplification of the indeterminate form of infinity over infinity. Okay, let's start here. Evaluate len x, len x over c sec x as x approaches to 0 from right. Okay, if I substitute the first step, substitute directly. Okay, lem 0 from positive. Okay, c sec 0. Okay, this is equal infinity, but here c sec 0 we can write here c sec what is equal of 0. This is equal 1 over sine 0. This is equal what? This is equal 1 over 0. This equal infinity. This is infinity over infinity is a case of L'Hopital. Okay, good. This is the first step. The second step here, we can derivative. Apply L'Hopital. Apply L'Hopital rule. Okay, now how to do that? You should derivative the numerator and derivative the denominator. Let's see here len x over c sec x as x approaches 0 from right. This is equal derivative len x 1 over x, derivative sec negative c sec x times cotan x is good. Okay, we can find this lim as x approaches to 0 from right. Now we can substitute here. The second step, substitute x by 0. Okay, let's show you this. This is equal what? 1 over 0 minus c sec 0 times cotan 0. This is equal I think infinity c sec 0 1 cosine 0. I think also I think infinity. Here I think before the student I think maybe think about to apply L'Hopital again, but I think you should simplify this expression. Simplify this expression. You can write in okay, in another form. This is very important point to think about this before to move to apply L'Hopital again. Okay, here we can write this is equal lim as x approaches 0 from right. Maybe we can write like this: 1 over x, okay, minus c sec minus 1 over sine x times cotan x. This is, I think, you can rewrite this in another form. Okay, this is lim okay 1 as x approaches 0 from right. This is equal what? I think sine x over x times cotan x. Yes, we can write this like this because this is equal 1 over x times what? Times I think here minus times sine x minus cotan x. Okay, to get this, we can here we can split this fraction into two fractions. Okay, this is lim as x approaches 0 from right. Split this fraction into two fractions. Sine x over x times, I think, times what? 1 over cotan x. This is minus cotan x. Okay, to get it here, this is this infinity. This is equal lim x approaches 0 from right, sine x over minus x times lim, I think, the 1 over cotan tan x as x approaches 0 from right. To get it here, this is equal minus 1 times, I think, sine times 0, because tan of x sine